the City of Groton's new rebuilt water treatment plant. We're about to initiate phase 3 of a 5-phase project, which we've been working on for the past 5 years in planning and in construction. But first, what I'd like to do is walk you through the construction site and briefly explain the various components. The building is a combination of new building materials, building wrap of existing building, and energy conservation. Anticipating climate change characteristics, we have hardened as well as insulated the entire facility. GU's electric department designed and installed a new electric service at a more appropriate voltage with more resiliency, and our contractor tied that into the existing plant and new facility and paired that service with 2 new generators operating on a more environmentally friendly fuel. It's important to note that the water supply source has not changed. GU still draws from 5 interconnected reservoirs, the water from which has an appropriately designated good quality. As you can see here, this is the terminal reservoir, and the withdrawal is from what we call the low lift pump station. We are now in the new water treatment plant facility. We installed 2 transmission lines from that low lift station which you saw previously. And they enter the building here. Paired with that equipment, we have process control equipment where we monitor the coagulation process and we monitor pH and temperature as well. At the advice of science experts and with Department of Health approval, we did substitute inline stators for rapid mixing. So the next unit process in clarification turns upside down the process that used to be in the old plant. We used to remove the particles in water through gravity. The particles set it to the bottom of deep tanks. Now, utilizing the saturator hooked up to a compressor, we release fine bubbles into this chamber, which then attach to the upward flowing particles and bring them to the surface. These residuals of trapped flocculant and particles suspended in the water are removed continuously through a device, the timing of which can be operator controlled, and then these residuals can be skimmed off and put into a residual channel. These residuals are brought to our residual lagoons for further treatment. The clean water then goes to an effluent channel and prepares for filtration, which is the next unit process. We have 3 of these DAF units, each one rated at 6 million gallons a day, so that with 1 unit out, we are still able to meet the required 12 million gallons a day. Here there are 4 filter units. Each is capable of a nominal rate of 4 million gallons a day. The filters have a freeboard of 4 feet of water above and 3 feet of specifically graded granular activated carbon and a half-foot layer of sand at the base. Pilot studies and scientific tests of these granular activated carbon units aided in design and choice of media. The filters utilize a scientific process of adsorption, which is different than simple mechanical filtration. Adsorption, a natural process, can remove very tiny particles or even dissolved contaminants. The process is similar to a magnet on a fridge, but on an atomic or molecular level. The bottom line is a filtrate which is ultra pure. As with the previous dissolved air flotation process, GAC units were selected for removal of emergent contaminants of concern and are continuously monitored for efficient and regulatory compliance. Supervisory control and data acquisition through computer systems, termed SCADA, allows operators to view and control all the unit processes, mechanical and electrical equipment control. Alarms are both local and remote. All parameters can be trended for regulatory compliance as well as troubleshooting. Data can be shared with other devices at varied secure locations. Here an operator selects the data from the computer SCADA system and puts it into a formal report. Right now, he's observing. Then an operator switches to a device where he can control and operate the equipment. And every move the operator makes will be saved on the SCADA system. Part of our heat and cooling system is a geothermal water-based loop system supplemented with fossil fuel. Here you see part of the loop system. These new chemical systems, sodium hypochlorite for disinfection, and later we'll show you sodium hydroxide for pH control, were actually part of phase one of this project. And once approved independently by the Department of Public Health, they were installed by GU trained staff. They've been in service for a while and are completely operational. You will notice the redundancy in supply and application via the many metering pumps. As with all processes, there is a great deal of safety and process control, as well as the redundancy you see here in the 4 metering pumps. This is the old bulk lime system used for pH control. The new system, sodium hydroxide, ensures energy conservation, operator safety, and exact dosage to the treatment water. All of this aged infrastructure will be removed in a demolition phase of the project under phase 5. This is the electrical room, which is tied into the new 480 volt service room. This room is a repurposed room. This is where Unit 1 filtration used to take place. Notice the sophistication of all the devices. All the devices have visual displays and visual and audible alarms. This cabinet houses a typical variable frequency drive, which is paired with a discrete motor. The VFD's solid-state controls are more energy efficient, up to 50%, and add years to the life of equipment and can assist an operator obtain the exact result required. This is the new high lift pump room, which was actually part of phase 2 of the project. These 3 pumps, each rated at 6 million gallons a day, operate off of VFDs from the electrical room and can be viewed and controlled locally and from SCADA. They all have surge control equipment as well as manual operators so that we can service the units. Now we move into the intermediate pump room. They are utilized to draw water from the filtered water reservoir and fill the 2 water storage tanks to assist in both supplying the system and in backwashing filters. Note that one intermediate pump is larger. This 9 million gallon a day unit can pump directly into the distribution system, adding redundancy and resilience in the case of a failure with the other pump system. The 1 million gallon Baffle Clear well remains the same. The CT value remains the same. This clear well will be maintained at a fixed level and provide suction for intermediate pumps or an emergency suction for pumps going immediately to the distribution system. These two elevated water storage tanks together hold 2 million gallons. They provide a higher level of fire protection, redundancy, resilience, and a stabilization of system storage. They have internal mixing to avert high THM production. These units were also part of the Phase 2 of construction and have been in service matched with the new pumping equipment. They are monitored locally and through SCADA. Besides process control equipment, analyzers, and certified operator checks, GU staffs a state-certified water quality laboratory, which ensures compliance with all regulations and assists in advising on all source water and treatment operations. Now we're about to implement Phase 3 of our project, going online with the dissolved air flotation and granular activated carbon systems into the distribution system. This will be operator initiated under the surveillance of experts and with the guidance of the State of Connecticut DPH staff. Now that we're online delivering water to our valued customers, we will closely monitor this trial for 30 to 60 days. Subsequently, we will commence Phase 4, which is repurposing existing old filters as manganese adsorbers, and Phase 5, which is final demolition and final site work. A few acknowledgments are warranted. We appreciate the support of former Mayor Galbraith and present Mayor Keith Hedrick. We also appreciate past and present utility commissioners and City of Groton councilors for their contributions, and the city freemen turning out to vote in favor of this project. Most of all, a heartfelt thanks to the DPH staff, engineering, state revolving loan fund staff, and especially Lori Matthew, who has been involved in this project since its conception as a regional cornerstone. There are many other individuals and agencies too numerous to mention, but greatly appreciated. I can assure everyone that the highly trained, certified operational staff of GU's water treatment plant will meet all our expectations and continue to provide the public we serve with the best quality of water. Thank you.